Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have the question partition equal subset sum. Yeah. So first let's understand the problem statement. Yeah. So what they have given an integer array nums, return true if you can partition the array into two subsets such that the sum of the elements in both the subsets is equal. I have already explained what is actually mean by subset. There are three concepts altogether. One is known as subarray, another one is known as subsequence, and the third one is known as subset. So if you don't know of any of the definitions of what actually this means, so please go back to my previous day's video. There you can get the gist. But for this video purpose, I will explain what actually the subset means. Subset basically you can choose any arbitrary elements in complete random order of the given num. So that is considered as a subset of it. Yeah. So now if we can divide our nums array into two subsets such that the sum of the both the subset is equal. The sum of both the subarray subsets are equal. So now. I guess this particular problem is very standard and very commonly asked questions on most of the interviews, and I guess like almost everyone has solved this particular set of the question, that is of like, I have to say like subset, subsequence, and subarray DP. So this is on that category, like LCS category, longest common subsequence, longest increasing subsequence, LCS LIS topic. But yeah, for this particular question, I will give you the gist of this, how you have to build your intuitions to actually reach the final solution. Yeah, so very initial go. If we can just look on the problem, one of the test cases. So here you can see that you can create two subarray, two subset, one with 155 with sum equals to 11, and the second one is altogether 11 alone, so we are able to make our nums to separate out in the two subset which has equal sum. Now for this particular test case, you can try all the possible arrangement, but you are not going to land on this. And guys, like that is a very common hint. So when your constraint is under 1000, so then obviously just think once of a 2D DP. Think once at least of 2D DP, because if your constraint like in the range of below 15, then think of like backtracking or recursion based solutions, and your constraint is more than 100 but less than of 1000, 2000, within this range, then think about 2D DP. And the main factors to apply DP is, do we have choice? Like if we are standing to a particular index, do we have choice? Yes, we have choices, right? We can either consider this particular one to include to our subset, or we can not consider it all to include to our answer, right? There are choices. Now before making choices, what actually the edge cases? So the very first edge cases, can you guys, like very blindfolded way, can you guys tell me if the sum, so let me just go to our favorite OneNote. So where did my space disk? Give me 1 minute, guys. Okay. So the fact is, what's the fact? So if let's suppose I have the subset. Let's suppose I have the subset of, sorry, Control C. Control C. So let's suppose I have a subset. Let's suppose I have a nums. So this is my nums array, and it has A, B, C, D, and E. So at very blindfolded, if the sum of my nums is odd, then can you guys tell me, are you able to create two subsets? Are you able to create two subsets of equal sum? Nope. We should not. Can we divide the odd numbers into two equal groups? Can we divide the odd numbers into two equal groups? Nope. So the very first edge cases. To this particular question, if my overall sum of my nums modulo 2 not equals to 0, if that is the case, if that is the case. So on that case, we can directly return a false. We don't have to do any computations further. What else? If now the fact is if it is odd, then we should be able to divide into two subset. We should be able to divide of two subset with some target sum. What is the target sum? Like every subset, what is the target? It is nothing but if my total is the total sum divided by 2, right? So my target, so think about, guys, like if we are able to form one subset with the target that is of total sum by 2, then can I, by very standard mathematical induction, can I say the other subset is already built? Yes, right? Because if you have total sum of total and you choose a target that is of total by 2 and you are able to generate a subset with your target that is of total by 2, then other elements is also going to belong of the other subset, and that particular subset to sum is also equals to your target. So we have to just think about to generate one subset of our target sum. What is our target sum? That is of total by 2. Now it is very popular and very important target sum DP question. Now it is boiled down to very important, guys. It is very important on interview perspective. It is of target sum. It is of target sum DP. So now I am assuming that you guys maybe know the target sum DP, but yes, those who don't know, for that I will explain how target sum DP is what. So on target sum DP, now the question is boiled down to we have an array, the same array that I already took, A, B, C, D and E, and we have built our target. That is of total is nothing but the total is what? Total is our sum of nums, right? And our target is total by 2. Our target is total by 2. Now we have to build a subset. We have to build single subset with our target. That is the problems where we have to. Now our problem is lying. So now if I standing is this particular elements, do I have choice? Yes, boy, you have choices. You can either take or you can not take. When I am standing at this particular index, I have choices, either take or not take. So for every elements, I have choices. I have choices. So now when we have choice, then it should be go to the recursion. Then recursion will do all possible take case, not take case, and finally it is able to generate all the possible scenario. So let's just quickly write the pseudocode for it. First we will write the recursive versions of it. First we will write the complete raw recursion, then just a one-liner tweak I will add, just a 1 minute one-liner tweak I will add, and it is going to be it is completely a DP solution. So what is actually the base of DP, boys? So the base of the DP is recursion. So when you are able to write the recursive functions with the required or minimum of changing parameter, your DP is already solved from that time. 96 to 97% of your DP is already solved. Now just you have to write a single or 2 lines you have to just write, and it is going to be completely a DP solution. So first we will focus on recursive code. Raw recursions first we will write. So our raw recursions is something like, we will call a helper functions. We will write an helper functions with some index. So that is my index. So currently I am at which index, and what is the current sum? What is the remaining sum? I know what I have to hit. I have to hit my target. So what is remaining sum I left to hit my target? So at any particular time, if my remaining sum is boiled down to 0, so can I return a true from itself? Yes. Then why are you from waiting, boys? We can directly return a true. We can directly return a true. Because our remaining sum, we are trying to hit the target. And every time when we are like getting some value, when we are consuming some value, we are reducing our remaining sum. We are reducing our remaining sum, right? We are doing that only. And at any particular time, we are able to make our remaining sum to 0. We should return a true. Return a true. What should be the other base case? If at any particular time, what is the other changing parameter? Our index is at any particular time, our index is hit to n, that is of out of boundary. Then on that times we can return a false for sure. We can return a false for sure, right? And else I have to try for building the answer. So initially I can consider for this particular index I am not able to build my answer. So I took my result as a false. Now I have two cases. One is take case. We can assign to take, or maybe better we can do our result update. Result. How we can do? It is of which operations? Bitwise or we can do bitwise or true false. How we can handle it? Bitwise or. So that is of bitwise or. Result bitwise or with what value? We are going to take it. So before taking it, guys, there is I guess one more check. Which is the check? If my this particular value, if my remaining sum minus, I am trying to minus some nums of I value, I am trying to nums of, or better it is nums of index value, I am trying to subtract some value to my remaining sum, because I am taking it because I am taking here. If it is greater than or equals to 0, then we can do. But if the nums index is very high, if my nums index is very high, then and if we are reducing the nums index to the remaining sum is going to be negative. So in that case, can we consider to take nums index? No, we don't have. So for take case, write it inside this if bracket, right? So now it is. So we are allowing to take. Now we will definitely go our index 2 plus 1, and what is our remaining sum? Our remaining sum is reduced by nums of index, right? It is as simple as that, guys. It is as simple as that. So our result is ready. So that is by take case. Now if our result, by taking it, we are able to make an answer, then do we need to check not take case? No. We can return a true from here itself. But maybe by taking we are not able to build the answer. So we have to consider the not take case. What is the not take case? We will call our helper functions to very next index, because we are not taking, and our remaining sum should be as it is. Our remaining sum should be as it is. No change in the remaining sum, right? And finally we can return our result. So exactly these things I have written. So that is of not equals. So the exact same things which I have written over the code, and I will explain what is the one liner changes you have to do to make it DP. So first try to understand the recursive versions of it. Then we will like neglect the DP part. I will tell like which particular portions you don't have to follow. Just focus on the recursive. So you can see just seeing the code now, you can see like 96 to 97% only the recursions which I have explained to you I have written, and 4 to 5% is the extra lines I have added to make it DP. So first we will see what actually Shouvik is told just in the one note. Is it written exactly the same things? So we will first go through that only. So I have initialized n to len of nums, total to sum of nums. If our total and 1, so that is of checking a bitwise versions of checking if a number is even or odd. I guess you guys is already aware of this, but if you don't know, well, just Google it. That is of very simple things. That is of bitwise versions of checking a number is odd or even. So how it is working? Because for every odd numbers, its last set bit is set. So if it is an odd number, then doing it to bitwise with 1, it is going to be true. So if it is so that means it is an odd number. So for odd numbers, we are not able to make it to two separate subset, two separate equal sum subset. So we are returning false. And if not, then we are initialize our target to total by 2. This DP we will go through later. Neglect DP. First we will see exact recursive versions we just see. If I have called the functions with index and remaining sum. So what is the sorry guys, I will just quickly explain what is the functions call. What is the functions call? What is the function call? What is the parameters we have called at the very first times our helper functions? So that is of return. You can return your helper functions, and what parameters you should call it. Index should be 0, and your remaining sum is nothing but the target sum at very initial. It should be your target. And when we are basically accepting some number, we are reducing our target. We will reduce our target. As simple as that, guys. So I have make the function call to helper with 0 and target. And I am written exactly the same things. If my remaining is going to be 0, then return true. We are able to build. If index is going to be out of bound and remaining 6 we are put above of it, so remaining is not hit altogether, so return a false. We are out of boundary and we are not able to make our remaining to 0. So what are you waiting for, guys? Then return a false directly. These portions I will explain. Neglect it. And we have initialized our result to initially false. And check if my remaining minus nums of index is greater than 0, greater than equals to 0. So this is the check. If my remaining sum minus nums of index is greater than equals to 0, so that means on that time only we are allowed to take it. So and we are taking it. We are going to next index and we are making our remaining sum to minus of nums of index. So that means we have taken the current remaining sum. We have reduced my remaining sums with nums of index because we have considered this nums of index to the subset that we are trying to build. And if at any particular time, if my result is formed, if by taking it, if we are able to build the result, then do we have to check for not take case? No need. We will directly return a true. These portions, every DP lines I will explain. And else if it is a not take case, I will go to exact next index and I have make it my remaining as it is. And finally we are returning our result. DP, I think you guys already got it. But if not, then let me go to the OneNote again. So now what is the changing parameters? We have it. So index and target sum. Right? These two are the changing parameters. So if you are able to identify your changing parameters, then create your DP with the size of the changing parameters. So we are trying to do so. So we are initializing a DP with minus 1. What is the column size? The column size is nothing but your second parameter. What is our second parameter? Is target sum. So our DP, just a quick note that just make it to not exactly your target. Just make it to plus equals to 1, because on some cases it is going to be out of boundary, because when you are trying to update with target value, so because it is a 0 index based, I think it is very intuitive. So take it to target plus 1, so that the target also you can put your DP. Otherwise you will able to put 0 to target minus 1. So to put target, you have to initialize your column to target plus 1. And what is our row value? Our row value is nothing but the indexes for underscore in range of index plus 1. Same reasons. So our DP is initialized. Now just see me, guys. Where we will put the checks. Just 2-liner checks we will put here just after the base case. Just after base case. Check if DP of index and remaining sum is not equals to minus 1, then if that is so, then don't need to consider, no need to calculate any further things. No need to calculate any further things. Return whatever your DP of index and remaining sum. Return from here down. And when you are calculating, before returning, on which lines we are returning. If I can make it a little smaller. So which lines we are returning? So after base cases, which lines we are returning? 1, 2, we have put this DP check after the base case, and post that which of the lines we are returning. So this is one line. We are returning from here. So here you can put before returning just put dp of index and the second parameter is remaining sum to what is the value we are returning, true. Just stored it guys, just stored it before you are returning. So this one extra lines you have to write, you have to write. And when we are another returnings we are doing from here. So again same things. Before returning, write one more lines, dp of index and remaining sum to result. I think so we are returning result, so yeah, storing the result here. So these extra lines, one extra lines we have to write. So this is the extra checks we have to put for checking if the value is present in the dp after the base cases. Then when we are returning, one lines we have to put just to store before returning, and another returns we are doing from here. So another extra lines we have put to store the value in the dp, and here we have initialized our dp. So these extra lines we have to add, which is exactly of zero brain power work. I personally feels initializing a dp is nothing. You know your changing parameters. It is of zero brain power work. And when you are just returning, just put to your initialized dp whatever the value you are returning. That is, I personally feels you don't need to. No one need to brain to just doing that. Just to doing that. So, but actually your brain is needed to write your recursions with minimum changing parameters. So now go to the code. So here you can see we are doing exact same things. So before of that, you can see like we have initialized our dp to exact same things we have discussed. -1 to target +1 for underscore in range plus, and we are checking if the value is present to the dp, return from here. And if it is not, before returning you are returning true na, so store it man, store it and then return. Here you are returning na man, you are returning results, store it and then return. That's it. Now it is going to be a complete dynamic programming solutions you have altogether written. So dp is as simple as that guys, if you are able to write your recursive functions with the perfect parameters, perfect changing parameters, then making it to a dp solutions, it's just a like left-handed work, just a left-handed zero brain power work, I personally feel. Yeah, so that's all about this particular question solutions. Now on time complexity part, I think it's very intuitive. You guys already got it. So it is nothing but of big O of what is the changing parameters of our dp? Big O of index into. So rather than writing at index, we can write it as in terms of n. Big O of n into sum of nums by 2. So that is the time complexity of the dp, and initializing a dp is going to take another this time. So I can write it of big O of 2 into n into sum by 2 and 2 going to get cancelled, or maybe I can write it as it is. That is of initializing my dp. The 2 factor is for the initializing my dp is going to be take n into sum by 2, and then the execution of the dp is going to be take to big O of n. And this sum functions is again going to be take of big O of n. So you guys see how I am writing the time complexity. I know every line execution time. I know every lines of my code execution time, and I am considering every of them. So please write it in that term, guys. So then you are going to be, so that's actually make you differentiate from the other candidates. You can obviously write big O of n cross total sum by 2. You can easily write it, but please give the interviewer a taste. Please provide the interviewer a taste. You know every line's time complexity you are using. Every lines you are writing, you consider the time associated with it. So please write it on these terms, or mention it verbally, And on space perspective, what is the space we are using? I'm not considering the recursive stack trace space. So on every dp is actually the recursive code altogether. I'm not considering the recursive auxiliary space. I'm just considering the dp space. The dp space is nothing but of big O of n plus 1 into what? Into total sum into, I'm writing it in terms of total sum by 2 plus 1. Total sum by 2 plus 1, because that is the dp 2D array we have defined. So this all about the time complexity and space complexity of the most optimal solution. There is an iterative versions of this, but if you want you can go through, but I personally feels the explaining more top of like which of the fancy code you are writing, I personally feels the more cleaner code, more readable code, or more granular code, or top of that, which code you are going to explain to the interviewer is more easily, write the code on that term. Write the code on that terms. Don't try to overcomplicate your code, just making it to iterative versions. So there are advantages of iterative versions. We are completely omit the auxiliary space, but 99% of interviewers are going to be satisfied with the recursive versions. If you are able to write the recursive versions and just with the one liner, two liners added, if you are able to convert to the DP, all 99%, 99.99% interviewers, I have to say, are going to be satisfied with that. So make your variables with proper namings, try to modularize your code and make the code more readable, which you are going to explain in a smoother term. So write your code, but you can go through the iterative versions. It is mostly like a similar form of like DP you have to create, and then you have to like go through the reverse versions of the iterations. Yesterday's question, there is a requirement of writing into the iterative versions, otherwise, so there are few forms actually. So when they have asked for true, false, length of that particular subset, subsequence, subarray, then your recursive versions is 100% going to be worked with as same time complexity of your iterative versions. But when they are asking for printing it, then on that times you need the iterative versions. You need the DP tables ready. You need the DP tables ready with the iterative versions. So just try to write the iterative versions when it's actually like 100% need. Otherwise, try to write on the recursive versions. That is my personal suggestions. That is completely my personal suggestions, because I personally feel explaining of recursive versions is more easy than the iterative versions. Yes, so that's all about this particular question solutions, guys. And if you are able to understand till this point, so I have just came to office and I have started to making the videos for you guys. So please show the support, and please do the subscribe. Please do subscribe to our channel, and please turn on the notifications when we are going to live with our next video. So that's it, guys. That's it for today. Meet tomorrow. Bye, guys. Bye.